Alright, today we're going to be looking at phases of matter. So, really quick reminder, matter is anything that is mass and volume, and all matter is made of atoms. Mass is the amount of matter something is made of, and volume is the amount of space that something takes up. So we have 4 different phases of matter. We're only going to focus on 3 of them. We're going to focus on solid, liquid, and gas. Plasma is a little bit more advanced. We're not going to worry about that so much this year, but if you want to know, plasma only happens at really, really high temperatures and really high pressures. You see it a lot in stars, like our sun is full of plasma, and what's actually happening is the atoms are being broken down, and they're being pulled from their orbital around the nucleus, which leaves behind only the positive ions. So you get a really weird mixture of these neutral atoms, these free electrons, and charged ions. It's kind of like a fluid, so liquid and gas, where it can flow around, but because of the charged particles, it makes these crazy electromagnetic forces. It's really cool stuff. And you can see some pretty cool videos if you look stuff up on YouTube. So we're not going to worry about plasma. I'm going to go ahead and cross that one out. But we are interested in solid, liquid, and gas. So if you look at our solid, this is a box of something. If I hit it, it might tip over, but it's not going to flow around. It's just a solid, hard object. Right here, imagine this liquid is in a container, like a beaker or something. If I tip that container, if I went from this, and I tipped my container over a little bit, that liquid would flow and change. It would match the shape of the container as much as it could. So these move around a little bit more. They have a little bit more energy. You see our energy is increasing as we go this way. And then finally my gases, they're just floating around willy-nilly. They go where they want to go. They are always going to be in the same shape as the container. You can compress gases a lot, but generally our gases are really far spread apart, and they move around really, really quickly. So there's something called kinetic theory, which states that all particles of matter are in constant motion. And of course, the higher the motion, the higher the energy. So we can see a really easy trend here. Our solids are very low energy because they don't move around much at all. Our liquids are going to be medium energy because they can flow around a little bit, but not as much as gases, our highest energy that we're concerned about, where they're flying around, they're bouncing off of walls. They can kind of do whatever they want to do. So we have a nice table here that we're going to fill out, and I'm going to do some drawings in here as we go along. So let's start with solid. We're going to do the what does it look like at the end. I'll draw in some pictures for you guys. How do the particles in a solid move? Well, they're very slow, and they vibrate in place. So they're always just little tiny shakes. They're very low energy, and the particles are very close together. When I say they have a definite volume and a definite shape, I mean their volume doesn't change, and their shape doesn't change unless something makes it change. So here you go, this is what a solid might look like. It's all these really closely packed together particles. Liquids, they move at a medium speed so they can slide past each other. They have a medium energy, and they're somewhat close together, not as close together as solids. They have a definite volume. Liquids do not always fill a container, but they take on the shape of the container. What I mean by that, if I took a beaker, a 100 milliliter beaker, and I put 50 milliliters of water in there, the water would fill half of that beaker, and it would take the shape of the bottom half of that beaker, but it would not fill the entire beaker. It would always be 50 milliliters. And here you can see my liquid particles. They're a little bit goofier, a little bit looser than my solids. And then finally I have my gas particles. Gas particles move very fast in all directions. They're really high energy and they're very far apart. And they have no definite shape or volume. So what that means, they take on the shape of whatever container you put them in. If you put gas into a beaker with a cap on it, it'll fill that beaker. Regardless of the amount of gas you put in, it will fill that beaker, and it will always be the same shape as that beaker. So you can see our 3 different shapes for our particles here. you can see how much closer together the solids are than the liquids, and the gas obviously are very, very spread out. So, here's a good way to identify our different types of phases. Question to ask yourself, can you measure the volume? If you cannot measure the volume, you're looking at a gas. If you can measure the volume, it's either a liquid or a solid. So next, let's ask if it has a shape. If it does not have a shape, it's a liquid, because liquids take on the shape of whatever container they are in. If it does have a shape, it's a solid. Solids always have one shape, regardless of the container. So right here, we can see our liquids take on the shape of the container. Our solids, like butter, are going to be a block of butter until it melts. Jello's kind of tricky. Is Jello taking the shape of any container? I don't think so. You cook it in a certain container, but that Jello is standing on its own, so I would call it a solid. Okay, ice cream. We've got a couple things going on here. So, let's first ask, can we measure the volume of this ice cream? Well, if I put this into a beaker or a graduated cylinder, I could find out exactly how much ice cream we're looking at. Does it have a shape? I would say that everything from here up has a shape. That ice cream is standing on its own, and it looks something like that. However, the stuff down here, that's all in the same shape as my container. So I'd say that ice cream can melt really easily and turn into a liquid, but anything outside of that bowl that we see with that specific shape, I would call it a solid. Here we have ice cubes. Do they have a volume? Yep. Do they have a shape? Yeah, absolutely. They're standing up on their own, they're not in a container. This is actually, it's hard to see, this is steam coming out of a teapot. So if you have steam coming out of a teapot, can you measure the volume of that? Not really, so it's going to be considered a gas. Snow all over a busy park, it looks like. So that's snow. You can measure the volume of snow. You could pick some of it up and put it into a container. And snow does have a shape. You can make a snowman out of it. You can make a snow fort out of it. So snow is going to be a solid. Peanut butter, once again, you can measure the volume of this container full of peanut butter. This one's a little tricky though, because it looks like the peanut butter might be taking the shape of the container, right? Well, what happens if you take that peanut butter out of the container? Will it have its own shape? Normally, yeah. So peanut butter is going to be considered a solid. Now this one's really interesting. These are red blood cells. These are flowing through your veins. They're really important for keeping your body working by sending oxygen all over your body. These red blood cells flow through veins. They have a volume. You could measure the volume of them. But do they have a specific shape? I would say as a whole, these are going to be a liquid, because you could put red blood cells into a beaker and it would match the shape of that beaker. If you put them out on their own, they would just flow out across whatever surface they were on. And that's going to end our section on phases of matter. Next up will be phase changes.